So this here is where we stopped in the note sheet from yesterday. Was this problem here? Line segments. Just talking about distances on a line. Now, points X and Y lie on the line WZ, as shown. Now, if they didn't give you this already illustrated, I would draw it out. I would just draw a line and put X and Z somewhere on the line. Where they're located really doesn't matter as long as it follows the guidelines kind of stated. As shown below, the length of WZ is 12. So it's telling us that the entire length is 12 units. So it's 12 units long. Let's see what else it tells us. It tells us that WY is 8. So this distance here is 8. And it also tells us that XZ is 10. How many units long can be, if it can be determined, is the distance from X to Y? So from W to Y is how long? 8, yes? The whole line is how long? So this missing section would be the amount for 12 minus 8, which is 4. So this length is 4. We can do the same thing with 10 and 12. 12 minus 10 is, so the distance over here is 2 and 4 is, so 12 minus 6 is, so the middle length is, but also since we found 4, 10 minus 4 is 6. So there are different ways we could have gotten there. Let's see here, very solid. 2, 12 minus 8 is 4, 2 plus 4. I think we went a better way about figuring out that it's 6. But any other questions on this here? All right. Let's look at the next one here. Marie is centering a tapestry on her living room wall. As shown in the figure below, the rectangular wall is 36 feet long in length. And the tapestry is 4 foot high and 8 feet in length. The right edge of the tapestry will be X feet away from the right edge of the wall, and the left edge of the tapestry will also be X feet away from the left edge of the wall. What is the value of X in feet? Well, the whole length is what? 36. Now our distance across, well, we have what? X, X, and so X plus 8 should be 36. Well, if we combine like terms, X plus X is 2X. Now, as Cadence was saying, we can subtract 8 from both sides. And if we subtract 8 from both sides, 36 minus 8 is, so 28 is equal to 2X. And then we can divide both sides by 2, which tells me that X is equal to That's all that we would need to do here. Any questions on any of this here? Yep. Because they will sometimes throw additional information in there to see if you can tell what's important and what is not. Okay. I'm just going to be nice today. I'm going to make the entire example set worth bonus points, and we'll do these here together. In the hexagon below, hexagon means what? Six-sided shape, yes? Is this a hexagon? It just has 6 sides. Because hexagon, we're used to seeing it as a regular hexagon, where it actually looks more of this kind of appearance to it. But hexagon is just talking about any 6-sided figure. It doesn't matter how it looks, as long as it has 6 sides, it is considered a hexagon. Hexagon below. Adjacent segments are perpendicular. That just means they make a right angle. And 4 segments are 4 feet long. 4 segments are 4 feet long as marked. So we've got 1, 2, 3, 4 segments that are 4 feet long. What is the perimeter of this hexagon in feet? So what would this be here? And what would this be here? And really, I can consider this all as one, and it would be. So we can say 8 plus 8 plus 8 plus 8 are 8 times, which is? So the correct answer is E. Any questions on this here? A square is partitioned into 4 squares of equal area, with each sharing a vertex at the center of the original square. What is the ratio of the perimeter of one of the smaller squares to the perimeter of the original square? So I would draw this out. So they say we have a square, yes? And it's a partition into what? 4 smaller squares, yes? Well, give me a length for the bigger square. Be nice if it's even. 16. So we could say that the entire length here, let me get a different color so we can see the difference. Here we can say is 16. And here is 16. All 4 sides would be 16, yes? Now it says that this is into 4 squares of equal area. So if they're of equal area, it means the lengths and widths are all going to be the same. So what would the lengths of each one of these squares be? Well, it would be really 8 and 8. Because we could look at area, because we would talk about it being 16 squared, which 16 squared would be 256. If we divide it by 4, talking about the 4 shapes, we would have 4. Square root it would give us 8. So each one of these would have a distance of 8. So, okay. Now the perimeter for any one of these here would be 8, 8, 8, and 8. Incidentally, that's what we just found not 2 seconds ago, yes? So the smaller is 32. What's the perimeter of the bigger one? So the bigger is 64. So if we're looking at 32 to 64, it would be so it'd be 1, 2, 2. So F, E and F. The scaling triangle below has a side length of B, A, and C. Centimeters. Let A prime be the image of A when the triangle is reflected across BC. So reflected across BC. So somewhere over here we have A prime. When the following, which of the following is an expression of this perimeter? So essentially we're saying we're adding this section here to it. Reflected across there, which would give us a length of B and C. Because here we have B and B added together, plus C and B plus B would be 2B plus, well, that's not one of the answer choices, but we can factor out the 2 from both terms, which would give us which would be answer choice D. And that's it. All right. Any questions on any of that there? Okay. Well, in Google Classroom, there is an exit ticket for this lesson.